Hello students. Now today we are discussing the next topic from the ionic equilibrium, that is the hydrolysis of the salt. So when you consider the hydrolysis of the salt, we know that neutralization. We know the process, that is the neutralization. So what is the neutralization? Neutralization is a process in which acid is react with base, giving rise to salt and water. So here strong acid is react with the strong base, giving rise to salt of strong acid and strong base and water. So exactly opposite is occur in the process of the hydrolysis. In the hydrolysis, a salt is reacted with the solvent, such as water is a solvent, giving rise to corresponding acid and base. So here Na plus ion and Cl minus ion of the NaCl react with water, giving rise to NaOH and HCl. So like this way, the first thing is clear that hydrolysis of salt is the exactly opposite process of the neutralization. In neutralization, strong acid is react with strong base, giving rise to salt and water. In hydrolysis, salt is dissolved in water, it completely dissociated to the corresponding acid and bases. Okay. Now, before we consider the process of the hydrolysis, what is hydrolysis and how hydrolysis is occur, now let us consider the type of the salts. So there are the four types of the salts. So types of the salts. So the type of the salts is on the basis of the type of the acid and bases we are using. So the first is a salt of strong acid and strong base. Salt of strong acid and strong base. Second is the salt of strong acid and weak base. Third is the salt of weak acid and strong base. And the last one is the salt of weak acid and weak base. So in order to consider these four types of the example, we must know the example for the strong acid and strong base. So first let us list the example for strong acid and strong base. So we know that what are the strong acids? The strong acids are example for strong acid are HCl, HNO3, H2SO4. Similarly, example of the strong bases are NaOH and KOH. So when we have to prepare a salt of strong acid and strong base, we require strong acid and strong base. Similarly, we also require weak acid. The example for weak acid are acetic acid, formic acid, carbonic acid, H2CO3 or hydrogen cyanide. Similarly, the weak base are the ammonium hydroxide, and sometimes we may use rarely copper hydroxide, but most extensively we are used as a ammonium hydroxide. So from this example, once we know the example of these four type of the acids, it is possible for us to prepare a salt of strong acid and strong base. So in order to prepare a salt of strong acid and strong base, we require strong acid and strong base. So we know that when acid is react with base, giving rise to the salt. So therefore I can make the example. Suppose NaOH is reacted with the HCl. So what it gives? It gives a NaCl. I write the example as NaCl. Similarly, if the NaOH is reacted with the NaNO3, it gives NaNO3. Sorry, NaOH is reacted with HNO3, it gives NaNO3. Similarly, NaOH is reacted with the H2SO4, it gives Na2SO4. There are the two hydrogen, at the place of the two hydrogen, there are the two sodium. Similarly, KCl, here is a KNO3. And the next one is a K2SO4. So like this way, we can prepare the example of strong acid and strong base. Now, when you consider example of strong acid and weak base, so we have the strong acid. Now we require the weak base. So weak base is the ammonium hydroxide. So ammonium hydroxide is reacted with the HCl. So what it gives? Ammonium chloride. It gives ammonium chloride. Similarly, ammonium hydroxide it gives ammonium nitrate. So ammonium hydroxide with H2SO4 is used ammonium sulfate. As hydrogen are 2, we require 2 ammonia. Similarly, copper. With the copper, generally one example you consider is a copper chloride. The other examples are not generally used. So like this way, you can consider example of strong acid with the weak base. Now similarly consider example of the weak acid with the strong base. So I write the example here. So what is the example of weak acid? Weak acid are acetic acid, formic acid, carbonic acid, hydrogen cyanide. And what is the strong base? Strong base is the NaOH and KOH. So let us prepare the example. So example are, so strong base I use as a NaOH, and weak acid first I consider example with the strong base as a NaOH. Now weak acid is acetic acid, so it gives sodium acetate, sodium formate, okay. Then it gives Na2CO3 and NaCl, okay. So these are the example of the strong base NaOH with the weak acid. So similarly, KOH can also prepare. It gives a potassium acetate, it gives potassium formate, it gives K2CO3, it gives KCl, okay. So like this way, we can prepare the example of the strong base with the weak acid. And the last one is the example for the weak acid and weak base. So when you consider the salt of weak acid and weak base. So we know the weak acid as the ammonium hydroxide. I can write here example of the weak acid as ammonium hydroxide, okay, and copper hydroxide. And the weak bases are these are weak acids. Weak bases. We now consider weak acids: acetic acid, formic acid, carbonic acid, and hydrogen cyanide. So let us prepare example. So ammonium hydroxide is used ammonium acetate. Again it gives ammonium formate. It gives ammonium carbonate, CO3. It gives ammonium cyanide. And this, okay. So like this way, these are the most commonly used example of weak acid and weak bases. So remember, when I consider example as NaCl, NaCl is example of strong acid and strong base. When I consider ammonium chloride is example of strong acid because Cl gives HCl, and weak base ammonium hydroxide. When I consider example of the sodium acetate, suppose I consider example of sodium acetate. In sodium acetate, acetic acid is a weak acid and NaOH is a strong base. And when I consider example as a ammonium acetate, where acetic acid is a weak acid and ammonium hydroxide is a weak base. So like this way, we can classify, there are the 4 type of the salt depending upon the acid and base we use. If both acid and base we are using a strong, that is a salt of strong acid and strong base. If any one of them we can use as weak, it is a salt of weak acid and strong base, or weak base and strong acid. And if both are the weak, then we use it is a salt of weak acid and weak base. So like this way, we are considering these are the 4 type of the salts depending upon the type of the acid and bases we are using. Now we consider the process of the hydrolysis. So what is hydrolysis? So hydrolysis is a process in which any salt when dissolved in water, it can be 100% dissociated to corresponding acid and bases. It can be 100% dissociated to the acid and bases. Depending upon the nature of the salt, the acid and base may be there. Suppose a salt is made up of the weak acid and weak base, then the corresponding acid and bases are the weak. If the salt is of the strong acid and strong base, the corresponding acid and bases are the strong. So what happens in the process of the hydrolysis? In the process of the hydrolysis, when what is a salt? Suppose we are using a solvent as a water. So suppose water is a solvent which can be hydrolyzed or which can be ionized and forming this. Okay. So when we added a salt in the solvent as a water, water is a neutral because in the water the concentration of the hydronium ion is equal to the concentration of the hydroxyl ion. As these both are equal, so solvent is a neutral. But when we added a salt, suppose the salt we are using is a Ba. When Ba is a salt, when we added, then the B plus and A minus of the ion of the salt is react with the water and forming BOH and HA as a base and acid. So what happened in the process of the hydrolysis? In the process of the hydrolysis, if the cations or anions of the salt is react with the water to produce either acidity or basicity or neutrality of the solution depending upon the nature of the acid and base. If our acid is a strong, suppose your acid is a strong and base is a weak. This is a strong and this is a weak. What happened? As acid is strong, his hydronium ion is higher than hydroxyl ion. At that time, the solution is acidic in the nature. But suppose base is a strong and your acid is a weak, then as it has a base is a strong, so hydroxyl ion concentration is more and this hydronium ion concentration is less. So at that time, the solution is a strong base. So depending upon the nature, if both are the same, or suppose both are weak acid and weak bases and both having the same value of Ka and Kb, then at that time the hydronium ion concentration and hydroxyl ion concentration are equal and the solution is a neutral. Okay. So what is the process of the hydrolysis? So hydrolysis is the process in which cation or anion of the salt is react with the water to produce either acidity or basicity or a neutrality of the solution, and that process is called as a hydrolysis of the salt. That process is called as a hydrolysis of the salt. So we also know that what is the hydrolysis? So hydrolysis is just like the degree of dissociation. It is just like the degree of dissociation. In the process of the hydrolysis also, we can also define the hydrolysis as a process. It is a fraction of total number of moles of salt hydrolyzed. Just like a salt dissociated or ionized, similarly the fraction of total number of the moles of the salt are hydrolyzed. So that is also your degree of hydrolysis. Okay. Now let us consider, now we are considering the various example for the hydrolysis of the salt. So first consider the hydrolysis of salt of strong acid and strong base. Now let us consider the hydrolysis of the salt of strong acid and strong base. Now for which I use a salt of strong acid and strong base, that is a NaCl. So NaCl when reacted with the water, what happened? It gives NaOH and KSCl. NaOH is a salt. When it is reacted, the Na plus and Cl minus ion of the salt react with water, giving rise to NaOH, that is a strong base, and HCl as a strong acid. So like this way it goes. Now what happens? When NaCl is dissolved in water, as NaCl is salt, it can be 100% dissociated and giving rise to corresponding acid and bases. Now suppose the acid and bases, when you hydrolyze, what happens? It gives NaCl, this NaCl plus hydronium ion plus OH minus ion. Okay, it gives like this way. So when you consider the process of the hydrolysis of the salt of strong acid, in this process the NaOH contain the Na plus ion and OH minus ion. HCl contain H plus and Cl minus ion. So what happened? This Na plus and Cl minus ion cancel with each other, and what is remain? It only contain water in contact with this ion. And when acid and base are react with water, here it has Na plus ion it has a Cl minus ion, OH minus ion, H plus ion or OH minus ion. What happened? So when they reacted, it gives Na plus and Cl minus ions. What happened? Again this Na plus and Cl minus are cancelled and it has a hydronium ion and OH ion. Okay. So here therefore observe that as a salt of strong acid will be hydrolyzed, the given process will be not to be carried out to be processed as a hydrolyze, because if it is hydrolyzed, then whatever the common ion, they can be cancelled and the solution contain only water in contact with ion, and therefore it is said that the salt of strong acid and strong base is not hydrolyzed. Okay, again repeat. So why the salt of, the question is that why the salt of strong acid and strong base do not undergoes hydrolysis. So why the salt of strong acid and strong base will not undergoes hydrolysis? Because when the salt of strong acid and strong base when you added in water, as it is a salt of strong acid and strong base, in the both sides whatever the common ions are there, they can be cancelled and the solution contain only water in contact with corresponding ions, and therefore it is said that salt of strong acid and strong base do not undergoes hydrolysis. Now let us consider next is a salt of strong acid and weak base. Strong acid and weak base. So for which I consider example as a copper sulfate. As a copper sulfate, so it is a salt of strong acid. Yes, it is a salt of strong acid if I use a water. So H2SO4 and copper hydroxide. H2SO4 is a strong acid and copper hydroxide is a weak base. So copper sulfate is an example of strong acid and weak base. So when copper hydroxide, it is a salt, when you dissolve in the water, it can be dissociated like this way. So it gives Cu plus 2 and so this Cu plus 2 plus SO4 minus 2. When react with water, it gives corresponding copper hydroxide and H2SO4. Okay, like this way. So I say again right here, suppose a copper sulfate, when you dissolve in water, I write here aqueous, it is a salt, it gives Cu plus 2 and SO4 minus 2 ion as aqueous. I can write the equation by the same way. Copper sulfate when react with water, it gives copper hydroxide and H2SO4. Means in the ionic form, copper sulfate when dissolved in aqueous solution, it gives copper plus 2 aqueous and SO4 minus 2 aqueous. So what happened? In the reaction mixture, now you have the ions of copper plus 2 and SO4 minus 2. As SO4 minus 2 is react with the water, it has no actual tendency to react with water. It have tendency to form H2SO4. It have tendency to form H2SO4 and H2SO4 is a strong electrolyte. It observed that when a copper sulfate is dissolved in the water, the given solution is acidic in the nature. The given solution is acidic in the nature. So why the given solution is acidic in nature? Because when copper sulfate is dissolved in water, it gives Cu plus 2 and SO4 minus ion. Okay. Here, these copper plus 2 ions have a tendency to react with water and forming the copper hydroxide. It can forming the copper hydroxide like this. Okay. Similarly, if this copper have tendency to form the copper hydroxide ion. Okay. If I have to balance this reaction, I can balance it like this. So it have tendency to form the copper hydroxide ion. Okay. So it observed that when the solution and SO4 minus have tendency to react with the hydronium ion and forming the H2SO4. So when copper sulfate is dissolved in water, the corresponding turbidity is obtained. The turbidity of the solution is obtained. So why the solution has a turbidity? When copper sulfate is dissolved in water, you are forming the copper hydroxide, and copper hydroxide is not soluble. It is insoluble. It forms the whitish colored solution, and therefore it is called as a turbidity. So copper sulfate is dissolved in water. In the solution you obtained is a turbid. In order to clear this turbid solution, we are adding a small amount of the acid. When we added a small amount of the acid, the concentration of the hydronium ion is now increases and the process is occurring in the reverse direction. And when the process is occurring in the reverse direction, the whatever the excess of the hydronium ion is reacted with copper hydroxide and it gives copper plus 2 and H2 water, means the copper hydroxide can be dissolved and you get a clear solution. Okay, and therefore it observed that in order to make the copper sulfate solution clear, we add H2SO4. So what is the nature of the hydrolysis of the salt of strong acid and weak base? The nature of the hydrolysis of the salt of strong acid and weak base is acidic in the nature. What is the nature? It is acidic in the nature, and as it is acidic in the nature, it turns blue litmus to red. It turns blue litmus to red. Remember, a salt of strong acid and strong base is neither undergoes hydrolysis. Therefore, that solution is neutral. But salt of you consider the hydrolysis of the salt of strong acid and weak base. As acid is stronger, the solution is acidic in the nature and it turns blue litmus to red. So that is the nature of the hydrolysis of the salt of strong acid and weak base. Now let us consider another example. If you consider a strong base and weak acid. Now consider example of strong base and weak acid. Now let us discuss what is the nature of the solution of the hydrolysis of strong base and weak acid. For this I can consider example as a sodium acetate. I can take the example as a sodium acetate. When the sodium acetate is dissolved in the water, it gives acetate ion and Na plus ion as aqueous. Okay, I can write also by the same way. If the sodium acetate is dissolved in water, what it gives? It gives acetic acid plus NaOH. So acetic acid has acetate ion, NaOH has Na plus ion. Okay, so like this way we can represent this of this. So what is the nature of the hydrolysis of the salt of strong base and weak acid? As the solution contains strong base, the solution is a basic in the nature. So how it is basic in nature? Look here. So this again, this Na plus is a stronger. It have a tendency to form the NaOH. But acetate ion I is a weaker. So when it react with the water, it forming the acetic acid and the hydroxyl ion. As the solution has more hydroxyl ion, the solution is a basic in the nature. The solution is a basic in the nature, means it will be turns your red litmus to the blue. It turns your red litmus to blue. Okay, so what is the nature of the hydrolysis of the salt of strong base and weak acid? It is a basic in the nature.